Hi there everybody. Today we're going to work on some specific heat concepts and problems. It is an intensive physical property of materials, which we've studied about earlier this week. So today I'm going to show you how to work some problems, and we're going to do a lab on specific heat doing next Monday. So I wrote the definitions for specific heat here again, and you should have your notes out right now and go along and work the practice problems with me. Just to recap, the specific heat is a substance's ability to absorb and retain heat, or we can also define it as the amount of energy needed to raise 1 gram of a substance 1 degree Celsius. So this information starts on page 520 in your textbook. So can you please take out your textbook and turn to that page now. There is a table that we're going to use and some problems that we're going to work. So I'll pause here for a second while you get your books out. Okay, so specific heat, when you're on page 520, and I'll show you my book here. On page 520, there is a table that has some of the specific heats for different substances. You can see that water, they're in descending order, and water has the highest specific heat of anything on this table. Well, this is liquid water. Notice the L after the water in parentheses. Solid water, which is ice, has a different specific heat, and water vapor has an even lower specific heat than that. So keep in mind that the state of matter of the substance makes a difference. If you have water, you have to make sure you're using the correct specific heat depending on whether it's a solid, liquid, or gas, which is true for other substances too, but this one is just the most common, so it's on the table. But here are some specific heats, and notice that some things have really low specific heat. We talked about aluminum foil and baked potatoes. Look at the specific heat of aluminum compared to water. Aluminum has a really low specific heat, so it can change its temperature very rapidly. Okay, so we can look up some specific heats here. Now let's get to the calculations. So first of all, we need to know how the equation for calculating specific heat. And as you can see in your book, the equation for calculating specific heat is Q equals M times lowercase c times delta T. And sometimes you'll hear this referred to as MCAT. This kind of looks like an A, so Q equals MCAT. But the Q refers to energy, heat energy. Please copy this down in your notes. We'll be using this formula quite a bit this year, now and in second semester. So heat energy, which is measured in joules. Joules is the metric measure for calories. Mass, M is mass, and mass is measured in grams, times the specific heat. Lowercase c stands for specific heat. And be careful, heat energy and specific heat are different things. So really pay attention to which variable your problems or the lab is asking for. So C is specific heat, and that's measured in joules per gram times degrees Celsius. Looks like kind of a crazy unit, but that's what it is, right? It's how much energy is required to raise 1 gram of a substance 1 degree Celsius. And then delta T means change in heat, or sorry, change in temperature. I'll abbreviate temperature. This Greek letter delta, that is always going to mean change in science. So, and when you find the change in something, you subtract. You take the final minus the initial or the starting temperature. So that's always how you find change in temp. Oops, probably shouldn't put those in parentheses. And of course the units will be degrees Celsius. Okay, so this is the equation. So you'll be given, there are 4 variables here: heat energy, mass, specific heat, change in temperature. And what you'll do is you'll solve for one of these variables problems. So let's look at page 521, and we're going to work problems 4, 5, and 6. So here's number 4. Number 4, first you want to identify what's in the problem. It says if the temperature of a 34.4 grams of ethanol, so that's our mass. And I do expect you to identify the variables. This is a problem-solving strategy that's going to help you work problems later in the course. It's ethanol, and it increases from 25 degrees Celsius to 78.8. So our change in temperature is going to be the final temperature minus the initial temperature. And I use just a subscript to differentiate between the final temperature and the initial temperature. So in this case, it's going to be 78.8 degrees Celsius. That's our final, and it started at 25 degrees Celsius. So our change is 53.8 degrees Celsius. Okay, so I've got M, I've got delta T. It says we're dealing with ethanol, so that's, you can look up the specific heat of ethanol on the table in your book on page 520, and ethanol is 2.44 joules per gram times degrees Celsius. And it's asking us to solve for the heat, right? How much heat is absorbed by the ethanol? And Q is heat. So that's what we're solving for. So we just plug our numbers into MCAT. So Q equals MC delta T. So Q equals 34.4 grams times our specific heat, which is 2.44 joules per gram degrees Celsius, times 53.8 degrees Celsius. Okay, notice how our units cancel. Degrees Celsius cancels, and then grams cancels, because both of these are in the denominator, and these units are in the numerator. So I'm left with joules, and that's what I want, which is the unit for heat. So Q equals, and when you multiply all these numbers together, you get 4,515.76 joules, which now we need to round to the correct sig figs. Up here we have 3 sig figs, here 3 sig figs, and here 3, so we need to round this to 3. So Q is 451. Those are significant. That's just a placeholder, so it's not. So there is our answer. Okay, now let's do number 5. Number 5. 155 gram sample of an unknown substance. Okay, so we don't know what the specific heat of this thing is. It's unknown. It raises the temperature from 25 to 40. So our change in temperature is 40 degrees Celsius minus 25.0 degrees Celsius. So we have a change in temperature of 15.0 degrees Celsius. And it says it absorbs 5696 joules of energy. And we need to calculate for C. So here's our equation again. Q equals MCAT. We need to solve for C. Excuse me. So let's solve for C before we plug in the numbers. So since these are multiplied by each other, we're going to divide both sides by M and delta T, so that cancels. So our specific heat is going to equal the joules of energy divided by the mass times T. So Q is 5696 joules divided by M, which is, let me move this up here, M, which is 155 grams, times delta T, which is 15.0 degrees Celsius. Notice that none of our units cancel out, so our units are going to be joules over grams degrees Celsius. The number, so I take 5696 divided by 155 divided by 15, and I get 2.4499 joules per gram degrees Celsius. Okay, almost done. Sig figs in the problem. The fewest we have are 3, so I need to round to the first 3 places here. So that makes this 9 rounds that up to a 5. So I have 2.45 joules per gram times degrees Celsius is my specific heat. And when I look, it says identify this substance. When I go back over and look at the table, it looks like the closest is ethanol. So I've probably just combusted ethanol. So we'll write that down. This is ethanol. Okay, I'm going to do one more, number 6. It's a little different. It says challenge, but it's not really that challenging. 6, we have a mass of gold, so of 4.50 grams. And gold, we can look up the specific heat in that table. It's the very bottom one, and it says 1.29 joules per gram degrees Celsius. And it says it absorbs 276 joules of heat. So the heat, and remember, you have to keep heat separate than specific heat. 276 joules. Anything that's joules is Q. It's just the heat. What is this? Oh wait. The initial temperature. Okay, so we don't have a delta T this time. We have the initial temperature. We know that delta T is the final minus the initial. And we just know the initial. Our initial is 25.0 degrees Celsius. We don't know TF. Okay, and it says what is the final temperature. So that's what we're calculating for. We're going to try to figure out what's TF. So let's write our equation. And since we're trying to solve for TF, let's go ahead and write what delta T means in here. Q equals M, and delta T means TF minus TI. So let's solve this now for TF. So we have to divide both sides by MC, and that will equal TF minus TI. Now I need to move this TI to the other side, so I have to add TI to both sides. So TI plus Q over MC is going to equal TF. Alright, so TI was 25 degrees Celsius plus Q, which is 276 joules over 4.5 grams, and C is 0.129 joules per gram degrees Celsius. Okay, so that's going to equal TF. So when I do this, so take 276 divided by 4.50 times 1.29, and then when you get that divided, add 25, and what we end up with is 25 plus 475.45. So our final temperature is 500.45 degrees Celsius. Now let's look at our sig figs. In our problem, we have 3, so this would end up being 3, this would end up being 3. So we're going to end up with a final temperature of 500. We need 3. We need all of these, so I'm going to write it in scientific notation. 5 times 10 to the second degrees Celsius, and writing it in scientific notation tells me that all of these zeros are significant. If I just write 500, that would be only 1 sig fig. Okay, so there's our final answer. So for tomorrow, I'm going to have you, I would like you to work 4 more of these problems. So here is the sheet, and you need to do 1 through 4 for tomorrow. And then also, I'd like you to prepare for the lab. So here's, you picked up a lab sheet on the way in. If you didn't, it's on the counter over by the door. So what you need to do is read through the instructions and how to set up this lab, and then on the back, your pre-lab is to sketch a diagram of how you're going to set up all of this equipment in order to do the lab. You will not be able to start the lab until you have this sketch done, and make sure you read the instructions, label your equipment, and make sure you draw arrows showing how you're going to transfer the materials from one container to the next. Your metal is going to be a cylinder similar to, oh boy, I can't draw, but yours, it's going to be a cylinder similar to the aluminum that we did in the density lab. Alrighty, so that's your assignment, the 4 problems and this pre-lab sketch. See you guys tomorrow.